Hi guys. So in this video clip, I'm gonna quickly demonstrate how to run a stacked ensemble models. So let me share my screen. And so this is my, Citrix platform and Enterprise Miner. I just wanted to remind you what is a stacked ensemble model. So in a stacked ensemble model, we merge prediction outcomes, prediction probabilities from individual models. Say we already ran decision tree, a neural net, classification tree. Then we first merge those prediction outcomes from individual models. And then we generate a metadata set that includes those predicted probabilities from those individual models. Then we run another model, say decision tree, a new decision tree, using those metadata set to predict the target. And if you think about it, this is going to be, so on your diagram, you will make those changes. So you already ran individual models, and you first add a merge node, followed by a metadata node, and you add a new classification model. So say, we are using we are adding a new decision tree in this case. Switching back. So this is our diagram. So if you recall, we have compared decision tree number one on, minimizing error rates, misclassification rates, and the other one on, minimizing average square errors. Thirdly, we had a logistic regression. Fourth, we had a neural net. So these are 4 individual models. So the first step is we should merge the prediction outcomes, prediction probabilities from these individual ones. So let's grab a merge node first. So where is merge node? Yeah, it is under sample tab. So you should bring that. Onto your diagram, and here's the merge. And simply connect the individual models to a merge node. See? So we have 4 individual models. Now a link to a merge node. And then I'm gonna insert a new node named metadata. Metadata, I believe it is under utility. There we go. And you connect merge to meta. And in order to, before you make any modification on the metadata node, you need to first run the merge node. So right click and run this. Yes, this is gonna take some time for it to run. So I'm gonna pause my recording and then we're gonna come back. Just pause. So now we have the result. So the merge node has been run. And next step is, click meta node And we're gonna make some changes here. See, if you look at the PowerPoint slide now, the PDF documents. So within the variables node, we are going to allow those. I mean, here it lists up 4. We're gonna also use 4. I mean, prediction outcomes from 4 individual models. Those predicted values will be used as input for the in-swing model, the new classification model, which we'll bring in shortly. So keeping that in mind, so here is a metadata. And from the properties panel window, select variables and click train. And it will take you to the same interface you saw earlier, this one. Then the prefix P represents predicted, and you will see the name of your target. And the reason why we have 1, we will choose those with 1 as opposed to zeros. 1 meaning that probability that the target taking the value of 1, the primary outcome, according to model 1, according to model 2, model 3, model 4. So hopefully the new window will pop up soon. Then we will quickly change the values, change the new roles from default to input, meaning that we're going to use those predicted values from 4 models, 4 individual models, as inputs for the following model. It's taking some time. So let me pause one more time. Okay, so from this window, scroll down a little bit, and I'm going to expand the first column name so that I can easily find variables starting with P as prefix. So these are the ones we need. So predicted values from neural net, logistic regression, tree classification with the misclassification rate being minimized, and another tree where we minimized average square errors, right? And B1 stands for the primary outcome. So essentially, this is probability of elapsing donation by neural net, by logistic regression, by trees. And within this new role column, we are changing its role to input. So make a 1. One change while you select those 4. So we have input, 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 and input. That is pretty much it. So we are only using this 4 as inputs for my subsequent analyses. So as soon as those changes are reflected, what I'm going to do is I'm going to bring in a new decision tree and add it next to a metadata node. Things are slow this morning. And you connect metadata to decision tree. And here, we're going to perform the subtree assessment plot, the subtree assessment, and let's say I'd like to minimize average square error on a validation set, of course. So I'm not making any further changes here. So, we haven't run metadata node, so you should run it. And then you run, new decision node, decision tree node. So that's pretty much all you have to do. So I'll just click this, and it's going to run all the, it's going to double check all the preceding nodes, whether they were run properly, and you will run this newly added metadata node, and then you will run the new decision tree. So after it complete running, please check back the results. Then you will see something like this. So from the new tree, you may see one of your individual models. Say it can be a neural net, it can be a logistic regression, right? So say, and you will see exact cutoff point. So if, say, the predicted outcome, the probability estimate greater than 70% by neural net, right? And then it takes the right route. Otherwise, left route. And then within this node, you will see a potentially different individual model. Say here, the old classification tree. So according to the your individual classification tree, if probability estimate greater than, say, 60%, different cutoff value, then it takes the right route, otherwise left route. So you should be able to interpret the results as well. So I will let you let you explore those results at your own, and I'm going to stop recording. Hopefully this is helpful.